Hello everyone, my name is Joe Scorsone, channel's called Ethernet. In today's video, we are going over episode 18 of the Quant Finance Output to Code. We're going to be doing a KMeans analysis on the Dow 30 today. Going to group them or cluster them by returns and by volatility. So we're going to get into how we're going to do that in this video, in this code. Pretty useful technique, I think. Pretty cool to visualize some stuff, and I think it simplifies it. I think it simplifies this process quite a bit. I think that KMeans is a great tool for it. So yeah, we're going to hop right into it. Thank you guys for all the growth on my X account. Really appreciate that. Make sure that you guys follow this for all the updates. I'm working on a new algorithm for my algorithm with LuxAlgo, working on a new tool for it. And I'm also thinking about updating this one so that way, like right here, we have 2 bullish alerts in a row. So only put one label and just kind of continue the stop loss and get rid of the numbers. Just some ideas that I have, just smoothing out the rough edges. But yeah, if you guys like to actively trade, you can hop on to the link in the description and learn more about this and subscribe and add it to your charts. So yeah, let's hop into our code now. So we're going to perform a K-means analysis on the Dow 30 to group stocks by return volatility. Use passcode to calculate Garch volatility, and then plot with Plotly. Cool. So some stuff from the series that's pretty much the same is the cache, the get data, and even these functions are the same up till here. Then we have our K-means, and we have our main. So yeah, if you guys haven't watched any of the other videos about Garch and stuff like that, I encourage you to, because this isn't a video about Garch, but it's very interesting. I think I like it a lot. But yeah, here is our function to actually get the parameters for it. So we have to minimize this likelihood function with the right parameters, with these parameters. And so yeah, that's how we get our alpha, beta, or omega alpha and omega alpha and beta. And so that's how we do that based on our log returns. Then we can actually calculate our Garch with those parameters with this equation, and that's our Garch. And so then our annualized return, we're going to use a cumulative sum. This is like a small detail, doesn't change results that much, but I'm just doing 252 over the length of our data, and then over the sum of it to annualize the returns. Not that crazy, not that important. There's different ways to do it, right? Like you could raise it to E and multiply it by like 252 and then add 1 at the end, I believe. I think that's a way. There's a ton of different ways to do it, not the end all be all. But that will return a tuple. That'll return the annualized volatility and the return, or the other way around. So that's why, or that's how we get it in our function, right? So we're doing this on the Dow 30. I just hard-coded all the names. I know there's a way to use pandas to just scrape it off of like Wikipedia or something, but I didn't really care. That's not what the video is about, so I just hard-coded them all. Felt weird to type in NVIDIA for this, but it's the world we live in. Set our start and end date, and then get our data. This is a dictionary. So it'll be each ticker and their data frame as a key value pair. So now we have to prepare our data. So for every ticker and data frame in our stock data, get the annualized return and volatility from that Garch volatility and returns function we just went over, this one. Then we're going to append this tuple, or this list. We're going to set it as a list, and we're going to append it to our X. Make sure it's a NumPy array. We could just set it to be a NumPy array from the start, no? Regardless, not very important. I don't mind being very verbose like this. Sometimes I like it. I always do. Do I have it somewhere in here? No, I don't, because we wouldn't have any nans. But I always like to do data equals data.dropNA. Just a me thing. Regardless, we're going to initialize our clusters. I'm not doing an elbow method in here because I think for something like this, it's okay to eyeball. It's okay to kind of tweak it out. And we also have a small data set. If we were doing something like the S&P 500 or the NASDAQ 100, even like the IWM, like the Russell 2000, like it might be better to actually do it. But they actually do the elbow method to find out what the best amount of clusters is. But just going to eyeball it for the sake of the video. So then we give it our X and then our amount of clusters. So now if we go into our K-means function, so we have an array of shape, samples, and features. So now our tolerance is just a really small number. And we need to randomly initialize the centroids with n clusters amounts of points from the dataset. So I'm just going to use a random seed, and we can just initialize our centroids are here with random data. Always use random data. Don't use zeros because something times 0 is still 0. Just a good rule of thumb, especially with machine learning. One day I was making a neural network and I initialized it with zeros, not with random numbers, and I was losing my marbles why these neurons weren't doing anything. Well, it's because they were always 0. Regardless though, we're just going to iterate through our max iterations. I just have that as default 100. And we really just want to shrink these distances pretty much. So we want them all to converge. So we're going to calculate the Euclidean distance. So that's what we're going to do here, the square root of x minus the centroids up to the new axis squared, and then dot sum it with the axis of 2. Each label is going to be the argmin of these distances. And so then the previous centroids, we're going to save it so that way we can update it, and then update it because we're going to save the previous centroids to see how close we are. And so then we're going to update it, right? So it's kind of like a forward step in a training process in a neural network. This is unsupervised learning. This is still considered machine learning. And so then for all of our clusters, we're going to avoid recalculating for any empty clusters, and we're going to set our new centroids to be the mean of the correct label. So yeah, that's how you then do that. Then we're going to return these centroids and these labels. It'll be a lot easier to understand what is going on if we were to visualize it. So that's what we're going to do right now. Wait for it to go through. There we go. So yeah, this is what it looks like. So on our x-axis, we have our annualized volatility. Oh, I didn't go over how I made the graph, but regardless. On the left, we have our volatility. On the right, we have our return. And so we can see here that NVIDIA is all the way up there. Of course, it's the most volatile and also had one of the highest returns. Amazon and CRM are kind of in the middle, lower volatility, lower returns. And so then most of our traces are down here. So these traces, like trace 32, trace 34, trace 33, those represent different groups. Like those centroids represent each, how do I want to say this? They represent the average position of the stocks with their clusters, if that makes sense. So kind of whichever stocks are closest to these ones would belong in that centroid. So these traces represent that. Of course, we have outliers, like NVIDIA is its own trace. There it is. So sometimes you have something like that. And then we have something like Amazon and CRM in the middle. So the clusters are where the groups of stocks come in. So each cluster is its own stock. Oh, not necessarily that. Each stock is a part of a cluster. So you'll see that Disney and Nike are both in cluster 1, Chevron and Verizon are in cluster 2. So we can see that these are all close to each other. These are also in cluster 2. So cluster 2 tends to converge to centroid trace 32. So the centroids is kind of like the summary of each cluster's average, right? So then we have cluster 1 is over here, a ton of other ones. And so the average is over here because it makes sense. We only have 2 ones out there. It wouldn't pull the average that much, right? And it's actually pretty much in the middle. That makes a lot of sense. You have 2 outliers, 3 in the middle. Yeah, it's pretty much right there. Same thing really for cluster 2. We have our ones over on this side, have our ones over on this side, trace right in the middle, pretty much more things around it, and then we just have more things on each side. And NVIDIA is its own cluster, or centroid really, and its own cluster, which is kind of cool to visualize it like that because NVIDIA has just been in a market of its own. So yeah, that's, I think, a way better way to understand it is to actually visualize it. We'll go over this graph really quickly. So it's just a scatter plot for the tickers for each cluster, each label, because each label I represents a ticker. And so then we're going to add the centroids, so just 4 centroids and centroids. We could add the centroids, and then just update the layout, use dark mode, show it, and then async.io.run. So yeah, I hope that you guys enjoyed this video because I'm sure that this now makes a bit more sense for you guys too, because now we can see how the traces actually. Oh, I just clicked Firefox, not Chrome. There we go. Now we can see how the traces or the centroids are pretty much the average. So we have clusters all around it, clusters on the side, it's right around there. So that's pretty much what's going on right here is each label, each cluster, right? We're calculating the mean of that. So then that centroid, that trace will be right pretty much in the middle, the average of it all. And then we just need to see how correct we are. If we ever get like really correct, then we can just break out of it, we're good. But in the meantime, we need to see how far away each axis is from it, get the labels from that, from those distances, make sure that we're using the right ones. And then, yeah, we can then fine tune it to get those clusters closer to each other and get those, well, get the centroids closer to the right clusters is how that would work, because the clusters are the clusters. These are what they are because of their returns and volatility. So we're trying to get these centroids closest to the right ones. And so here we can see that NVIDIA, I wonder if it's even, is it just right on top of it? I think it is, because NVIDIA is, it's the only one in this trace, so of course it's on its own. So yeah, I hope that that explanation helped you guys. Oh, I just realized my face was in front of it the whole time. NVIDIA's up here. Yeah, sorry about that. I didn't realize that my face was up there, but I don't mind how I explained that, so I'm going to leave it. But yeah, I hope that this code makes sense now. I hope that you guys are understanding what KMeans is trying to accomplish now. The company the business that I had that collaboration with, LuxAlgo, they have an awesome algorithm where they use KMeans clustering to optimize the look-back value for a super trend indicator. Super cool. When I first started, if you guys have been a long viewer of my channel, you guys would remember Prometheus. Kind of just dudded out, but I remember when I first started Prometheus, and before I started working with LuxAlgo, I saw that indicator. I was like, damn, that's going to be hard to compete with. It's a great one. It's open source. It's free. The developers and the people over at LuxAlgo are amazing. Go check them out if you don't get my indicator. But yeah, they're awesome people. They're cool people. And this is the technology. This is the mathematical technique that algorithm is based off of, which is super cool to understand it now, because they're trying to converge the centroids to the optimal look back value, which is a super cool way to apply this, because this is to explain kind of how to group stocks, and they use it in a way to kind of group look back values and find the optimal one. So yeah, just super cool ways to apply this kind of stuff. As you can see, my dog chilling. She was just hanging out. I'm gonna move her. This is Ellie. She's making an appearance. She just wants to go back to bed. But yeah, I hope that you guys enjoyed this video. Hope that you guys subscribe to the channel. Oh, you have a lot to say. Hope that you guys subscribe to the channel and stick around. I'll put you back. Hope that you guys check out LuxAlgo in the description of the video. Yeah, subscribe for more videos about the Quant Finance Algorithm code. It's day 18, which means that I gotta start pre-recording to have an upload on Christmas. But yeah, hope that you guys enjoyed this video. Hope that you guys have a great rest of your day. I'll see you guys in the next one. Bye.